just pull those in and have a look around and see what's changed. And look at a web server that I was working on last week, which uses sub-interpreters as a replacement for multiprocessing. So I just kind of wanted to go back into that experiment, recompile it, see what's working, what's not working, look at any bugs, and just kind of dig around a bit and have a bit of an explore. So yeah, if you're interested in this stuff, hopefully you might learn a couple of things. If you want to ask questions, you can. If you want to tell me something I'm doing wrong, you can do that as well in the chat. So yeah, I realize it's probably dinner time for a lot of people in the US, and it'll be the middle of the night for people in Europe. So this is probably going to be a bit quiet, but there's a few things to do. I did notice earlier though, actually, when I was looking at the changelog from the weekend, Guido's done some optimization stuff this morning, on the evaluation loop, which apparently makes it about 3 times faster. So I'm going to pull that change in a minute. He said the tier 2 interpreter, which is kind of around some of the really low level operations. So that's some changes. Okay, so let me switch to, let's close everything. Okay, so I'm in VS Code. I'm in the CPython source code. If you want to play along, you can get that from github.com/python/CPython. So once you've downloaded a copy, cloned it locally in Git, you want to go to the main branch, because that's where all the interesting things are happening at the moment. Everything else will be, I think they've got, yeah, so main is 3.13. Anything else that needs to be backported to 3.12 can be done, but any changes that are features or improvements will only go into main, which is for 3.13. Only bug fixes and security patches are going into 3.12 or anything below that. So yeah, just pull to the main branch. I'm going to download the latest changes from last week and then recompile. So I'm doing a couple of things on this local copy. I've got, so normally when you configure CPython, you would do it with, if you're doing local development work, you would do it with debug mode, which is called with PyDebug. The other flag I had was disable GIL. Although I did see some comments in the change log that they were going to rename it. So let me just check that they haven't. Enable GIL. To say it is still disable GIL, yeah. So let me just clobber it, because I might cancel. So the disable GIL flag is the new option, which doesn't disable the GIL yet, but it will do when all of the changes are done. So PEP703 is the making the GIL optional in CPython. This one got approved like a couple of weeks ago, and it's scheduled for release in Python 3.13. What it will look like in 3.13 is that when you run multiple threads using threading, then they should be able to actually execute in parallel, which they can't do at the moment. So the threads will share the same GIL if they're in the same interpreter. So when any one thread is running, it'll be, the others can't run at the same time because of the lock. So this PEP703 proposes to basically make the GIL optional, which sounds simple enough, but it is ridiculously complicated because Python's kind of built around the GIL as being there. So in the motivation and in the design, there is all the details about some changes that need to be done in CPython. And that laundry list is this issue in the repository, which is 108.219. And in this one, Sam Gross, who wrote the PEP and also has done this already in like a fork of CPython. So he's disabled the GIL in a fork, proved that it works. He's tested some applications, and that was kind of the basis for the proposal to get this kind of real parallel threading working in CPython, and then basically gone through all of his commits from that fork and then broken it down into kind of like an atomic set of changes that need to be made. And the idea is that if you make 100 changes instead of one massive big PR, then you can test each of the things as you go. So because this will likely introduce some, well, they don't want it to introduce breaking changes, but it probably will, then it is a flag. So disable GIL is a flag. And when you compile CPython from source, then you use the disable GIL flag. And then all of the binaries that you build, so like if you compile C extensions, they'd have this extra tag, which is T, so that if you build a package C extension, upload it to PyPI, then it will have a special tag. And that means that tag won't accidentally be installed by someone who doesn't have the GIL disabled, because they will have a different interface. So ABI is application binary interface. It's kind of like API, but ABI means like at the bit level, what the functions look like and what the data structures look like. So if you're importing things at a really low level, like the shared libraries or the DLLs or whatever they are, the ABI needs to be consistent. Otherwise, when you import it, it's going to try and access a bit of memory or use a data structure that doesn't actually exist or doesn't look like it should. So that's now clean. So if I rebuild, that takes a minute, so I'll just talk through some of this list. So yeah, there's some pretty big changes. So basically in this list, like the last commit will actually be to actually go and disable the GIL. So that's like the last thing that needs to happen. Everything else before that is basically all of the dependent changes to get to the state where the GIL can be disabled. And they're kind of broken into different parts. A lot of these changes are to do with the reference counting. So most of those have been done already. So the reference count for a Python object, that structure is changed. So the Python object structure at the C level has changed in this build. So it's basically 2 reference counts. There's the normal one, and then there's like a threading one. There's also something called bias reference counting, which has been implemented already. I think there's still some other changes that need to be pulled in for that, which uses that new structure. And then there's also a different memory allocator called memalloc, which handles, basically reduces some of the performance degradation on a single thread from introducing these changes. So memalloc is not part of CPython. It's a memory allocator that will replace CPython's memory allocator for Python objects. So those are kind of the basic, not basic, they're pretty complicated. Those were some of the original changes. There's also immortal objects, which is another PEP. Those have been merged in, and they were also related to Eric's subinterpreter PR. So it made sense for some types of objects to make them immortal, because true and false, for example, are Python objects. it only allocates a true object once and a false object once, and it reuses those references all throughout the interpreter. It doesn't make any sense to keep a reference count of those because you shouldn't ever not need true and false. It made more sense to just have an immortal object and then just keep it around. There's a couple of other things as well. Interned strings is another one. So if you have a string in Python, there's quite a bit of work to convert the ASCII or the actual text into a string object, allocate the memory, and then keep it around. And if you imagine you've got Python objects, like the name of a method, for example, or an attribute, or the key in a dictionary, these are all string objects. And if they're like hard coded in your class, so like the name of the method is not going to change, it's hard coded, then that could be a string that's been interned. Interned means it's been internalized, so it's been like almost like statically allocated. Not quite, but it's been allocated up front to make it more efficient. This is something I do on C extensions. When there's a string that I use a lot, I would create that string, allocate the object once, and then reuse that object reference instead of converting it to a string every single time, and it makes a huge difference in performance. Cool, that's done. Let's now compile it. Okay, so I've configured it with debug mode and the guild disabled, but like I said, the guild hasn't actually been disabled yet. So let's just compile that and then we can have a play with it. They are often, a lot of them are make something thread safe. And this is what I went into in the blog post, is that the connection between Eric's subinterpreter, like PEP and all the changes related to it, and the no-GIL work, is that even if you introduce subinterpreters and there isn't a no-GIL, a lot of C extensions are not thread safe. So having multiple GILs in the same Python process, which wasn't really possible before, is quite dangerous, because you've got C extensions where essentially people have allocated like a global on the C level, and then they're using that in different places. And that has never caused any issues before, because you've had the GIL and the GIL's basically locked it, so it kind of made it thread safe by default. And you think maybe that's bad design. The C extensions include ones in the standard library. So here you can see we've got simple Q, which is in the Q module in the standard library. That's not thread safe. The thread module itself is not the thread. Oh, that's strange. The thread module is not thread safe, apparently. Unicode objects. I mean, there's a lot of pretty important ones here. Weak refs. I mean, they're used like everywhere. The dictionary is not thread safe. That's kind of important. So yeah, Sam's kind of made a list of all the things he had to do to get to the point where he could disable the GIL. The thread safety, I think, is more critical in this change set than it is in the subinterpreters one. Because normally with subinterpreters, they're in a separate interpreter, so you've got interpreter state, whereas in the no-GIL, you're just doing you basically got a lock per thread. So it's a lot more granular. So what I've seen when I've just done subinterpreter work is that some things haven't worked, and the reason is because the C extension that underlines that software isn't ready for either subinterpreters or no-GIL. So it doesn't matter which one, like it still needs to be updated and tested. Okay, so we've got okay, so that's now compiled. So we've got Python up and running. So this is Python running with no-GIL and running with subinterpreters built in. I'm just going to install this. So when you do make install, that installs it as the default interpreter on your system. If you do make alt install, 3 .13. So I don't have to worry about my system accidentally using this as the default Python, because that would be disastrous. Cool. Okay, that'll take a minute. All right, so if I switch to the project I was working on, I need to wait until it's compiled before I try and use it again. But I'm using subinterpreters in this code, and using Hypercorn. So what I wanted to do with this app is basically when you run Gunicorn or something, Hypercorn, and you specify multiple workers, it normally spins up multiple Python processes. So each process has its own GIL, and you would spin up one worker per CPU core. So let me just switch on my activity monitor. You do one worker per CPU core, so you should be able to use all 4 cores, which is great. And as I went into in the blog post, multiprocessing is kind of like the way that people have always done that, and that's how you get around the GIL. If you've got multiple cores, it's you just run multiple Python processes. The downside of that is that Python processes are massive and they have a huge overhead, and also sharing data between the processes is quite slow because everything's got to be pickled, and pickle's not particularly fast. So subinterpreters are a way of having one process but multiple interpreters, and each interpreter has its own GIL. So what I did with this app as an experiment, let's just check on that. Okay, it's done. Cool. So 6A, just checking the version so that capital V. Okay, so I've got a virtual environment in here, and that virtual environment is using Python 3.13, which is a symlink to the one I just installed. So I'm just checking that's the one I just compiled 5 minutes ago. So let's run this, I guess. And I'll explain what's going on. Let's do 4 workers, and then I've got the Flask app. Okay, so how the app works is so Hypercorn has a config object. You can so the things I wanted to load was the application. So what's the web app I wanted to run, which is this one. This is just a really simple Hello World Flask app. So I'm going to set that. I'm going to get the number of workers, and then I'm going to create the sockets to listen to. And then I'm going to start the workers. So I've implemented each worker, each subinterpreter, I've implemented as a thread, which might sound weird, but when you start a subinterpreter, when you start and then run the subinterpreter, so you say run this code, that's a blocking call. So, if I'm running 4, then I want to start them, but do that in the background. So what I decided to do was to basically implement a class called subinterpreter worker, which inherits from thread, and basically just call the thread super, which sets the target to the run function. So when you create this thread and run it, it will basically just run this method. And then also use daemon mode, which means that if you kill the main process, then it kills the others. It's just an extra option. So this class will create a subinterpreter, which I'm using. This is the new API. And as I kind of went into in the blog post, this new there's two new modules coming for sub-interpreters, one called interpreters, one called channels. Interpreters is the interface to create interpreters and tell it what code to run. And channels is a mechanism for sharing data in between interpreters. So the import statement looks a bit weird because currently it's like a hidden module. But you import that _XX sub-interpreters. And I always rename it as interpreters because that's what it's going to be called in the future. And the same with channels as well. So create a sub-interpreter in this process, create a communication channel, and then copy across some other things. And then when you run the thread, I'm going to make a list of insecure sockets is a property inside Hypercorn. It decides which socket the web server is going to listen on, like network socket that I'm talking about. So one of the constraints you've got with sub-interpreters at the moment is that when you run them, the data that you can send to them over a channel, like the types, is quite limited because it's only immutable data structures. So that is byte strings, Unicode strings, bool, none, floats, ints, and tuples. So yeah, tuples and bools were the ones that were missing, and that's what I implemented the other week so that I could do this. But yeah, you can basically send a dictionary of data. So it doesn't support dictionaries. This is the argument basically that constructs the, and I'll show you what it does in a second. But so when it runs the interpreter, I'm telling it to run this code, and then to set some local variables with these names and these values. And each of these values needs to be shareable by sub-interpreters. If it's something more complicated, like a dictionary or like a class or something, you would just pickle that. But you've got the overhead of pickling. So that's keep it simple for now. So we've got a communication channel. So the things I wanted to send my sub-interpreter are give it a number so it knows when you like log stuff, like what number it is. Give it a list of sockets, which I cast into a tuple. Give it the path of the web app to start, give it the number of workers, and then give it the channel ID so that it knows which channel to listen to. And then the other thing I did was to implement a method called stop, which sends it a signal when it needs to stop. That's really important because Hypercorn normally uses async IO events, and you can't configure events on different interpreters. I'm not sure whether that constraint's going to change, but that's at least what I found when I was trying to get it working. So I've got this sub-interpreter thread class. So I create one, do it in a loop, start it, and then append it to a list of threads, and then basically just sit and let them run. Now the code itself for the interpreter is a string, which is not ideal. This is going to change. People aren't going to sit coding Python in strings. It's just how the interface currently works. You could like make this a function. Let me just do that, and then it's easier to read at least. If I change it to a function, this is easy to read. So when it starts the interpreter, this is the script the interpreter runs. The important thing is that when you start an interpreter, it's got more like isolation than a thread does. When you create a thread in Python, you don't need to re-import modules, or you don't need to it doesn't really have a startup. It kind of does have like a really small startup for threads, but it's quite simple. Whereas an interpreter is much more isolated. Like it has its own GIL, but you have to import all the modules again. It barely shares anything with the main process. Like it shares the memory allocator, and it shares some immortal objects. and there's a couple of other things, but like it doesn't really share much state with the main Python process. And that's kind of the point, is that for it to have its own lock, it really needs to be able to run in isolation. Yes, can you share, as a question, can you share nested tuples? Yes, you can. And that is actually, insecure sockets is a list of tuples. So that is a tuple. So one of the issues I had when I tried to figure this out the first time was, I said, okay, it's constructed the sockets, but sockets they're a class. So I couldn't share the class with the subinterpreter. So instead, basically what I did was make a tuple with 4 parts. The first part is the socket family type, which is I converted into an integer because it is an integer. The socket type, which is an integer, so I forced it to be an integer. The protocol, and then the file number. So that's basically a tuple of 4 components. And then I add them to a list. That should probably be a list comprehension, actually. Anyway. And then convert that into a tuple. So that is a tuple of tuples. I tested it like pretty deep. I can't remember how many, but yeah, you can do that. So when the subinterpreter basically runs as like almost like a mini Python process, this is the code it does. So it imports hypercorn. It sets up syspath for the. Actually, I don't even need that anymore. That code doesn't even mean anything useful. I can delete that. So yeah, import hypercorn. Sorry about my crazy VS Code setup. I've got inline errors, so that's why my screen is like orange and red. It's like an angry fruit salad. So I'm going to import all the things I need. So I need async IO, I need threading, I need channels, hypercorn, sockets, time. Now, so what I basically do in this is I go and convert that tuple of tuples, the insecure sockets variable. And it's underlined, so it's saying, well, you haven't even defined that variable, so where the hell is that coming from? And the answer is here, because when I said shared equals, it creates variables with those names and those values. So when the subinterpreter starts, those are already done. Alternatively, like, because when I had that as a string, you could make it an F string into like substitution, I guess. But if you want to be properly dynamic, you should do it this way, which is to create the variables by using shared data. So go through the tuple of tuples, which is insecure sockets, create a socket for those parts. So the constructor for the socket type in Python takes 4 arguments, and we've got a tuple with 4 components. And like I said, each of those can be an integer, which is why I cast them into ints. Set up the socket type, create a new config object, because I couldn't share it with the subworker, and create a thread. So there's a lot of threads happening here. So this thread is a signal thread, which I'll come back to in a second, and then run a function called async IO worker, which is part of hypercorn, which basically like runs the web server. And it takes an argument called shutdown event, which is supposed to be an event type that it will basically listen to, and if that event has been set, so if it's been triggered, then it will initiate like a clean shutdown. Because if you've in some async apps, fast API, I see this all the time, where you have like an event hook and you say when the app starts, run this code, when it shuts down, run this code. So like most web frameworks have got like a listener that says, okay, when someone's done a clean shutdown, like the app didn't just crash, but like when someone's shut it down cleanly, then run this special code to clean things up. So that's what the worker does. So things got a bit harder because async IO, you couldn't you couldn't share an async IO event with the sub interpreter, which is kind of what you would have done normally, because the signals don't work between interpreters. So what I did instead is I used this communication channel that I created here. So communication channel, you can basically send and receive any shareable type. So that's the same constraints that I said before, like all the immutable types. Yeah, so the question was, is there a way to add additional shared data after a sub interpreter has already started up? So yes, that's what the channel's for. So once you've done run string, whilst that code is running, you can't run string, you can't run that from somewhere else. So you can't like, it's not like a queue or like, you can't asynchronously tell it to just run bits of code. And the way this one works is that it runs like a service. So like once this is up and running, it will just run forever. Like you see here, this is just basically is on this line. So it's just sitting here running. If I click on that, then I should see my Flask application. I can do... My machine's being slow. Come on. Okay. AB is Apache Bench, which is a command line tool for spawning HTTP requests. I like lots of them. N is the number of requests you want. So let's do like 1,000 requests. C is the amount of concurrency. So like how many requests at a time. And then the URL. That's not helpful. So run 1,000, make 1,000 requests, but do 10 at a time. So if I do that, it does that. So I'm running 4 workers, but it's just done 1,000 requests. 95th percentile, 23 milliseconds is fine. But this is on like debug mode. So it shouldn't be fast anyway, because I've got like all the debug options in CPython. There's no optimizations enabled. So, okay, back to the signal thing. So here I created a thread. So this is a listener thread. So I started a thread inside the subinterpreter. So this is not one in the main one. This is a thread running in the subinterpreter. And that's this thread. And it just does a while true loop. And it listens on the channel. So remember I had that channel where I could send data. So receive is takes the channel number that you want to listen to, and default basically says if there's nothing in the channel, then just return the default value. If you don't specify default and you do receive, it will raise an exception saying there's no data. And I think the way I coded it was just to have a string. That's probably not the best choice of types. I probably should have just done an integer, to be honest. It's a bit it'd be simpler to serialize it, but I just thought a string just in case I might have different messages and stuff. So if the message is stop, then set this async IO event. So basically trigger the event, which, because it's happening in a separate thread, that would then tell this worker that a shutdown event has been requested. And if it hasn't, then just wait for another second and then check the channel again. In the class, then I implemented a stop method that basically just sends the word stop down that channel. So this is how you communicate between the interpreters: is you create a channel, you give them a number, and then you can send and receive data down there. I think so send also has another argument, which is like blocking. So by default, it'll be true. So if you do send, it will sit there and wait for something on the other end to actually receive the data, unless you specify it as non-blocking. So reason I've done that is because I've set an exception here. Say if there's a keyboard interrupt, then for each of the threads, run the stop method. So if I go here and press Control C, it will send the stop signal, and then it will have a bunch of exceptions, and then it will have a segmentation fault. Yeah, I'll come back to that bit. But so yeah, it kind of cleanly shut down. Like, it looked pretty clean. So it got the method, it sent a signal to the subinterpreter, and then it triggered an event, and then it did the other thing. So that kind of worked. And this is one of the few issues that I've had so far with subinterpreters and the no-GIL stuff, is that not all modules are thread safe yet. And I'm trying to pin down which one the hypercorn one is causing the most problems. But what was I testing? Okay, so that's actually, I'll come back to that. So it's shut down cleanly. I haven't really had time to look at this, why it's got a bad file descriptor. I don't even know if sockets are thread safe yet. This is the one that's more concerning. Oh, I've not seen that one before. Okay, that's different to normal. It might even be different if I run it again. Let me undo the changes. Oh, okay, that's new. This is a different error. Okay, this one. This is why the title of the stream is "Cutting Myself on the Bleeding Edge." Okay, what the hell's going on in this one? Hash table. So this one, I've seen this exception before. So this is nothing I've done. That is an assertion because I've compiled Python in debug mode, and debug mode comes with a whole bunch of assertions all over the code that say basically like this should never happen, and if it does, then just kill the process because that's bad. And that one is, where did it say? Hash table. Line 226. Okay, so there. But I bet if you run it again, it will disappear. Yeah, this is a weird one. I've seen that assertion before, and I couldn't always repeat it. So it looks like a race condition or something, because it doesn't always occur, but it does sometimes, which makes it really hard to debug. So what I was trying to do to debug it was, in VS Code, use the CPP debugger, which on the Mac would be LLDB. And then, because Python is a debug binary, then I can actually set breakpoints at the C level and stuff. And then run the worker. So let's run it and see if it crashes. So I know people are probably wanting to ask, like, what's the point in all of this? I kind of went into it in the blog post, but my theory is that when this is finished, so multiprocessing, the use of multiprocessing in Gunicorn and Hypercorn and stuff as the worker mechanism. So like when you've got 4 workers listening on 4 cores or 8 workers listening on 8 cores, like using multiprocessing is just the way it's been done because that's the only option pretty much. Like people use greenlets and stuff like that, but using multiprocessing as a way of keeping all of the CPU cores busy it's really the only practical option, and it's not ideal because the processors are big, they're heavyweight, they've got all this state which doesn't really need to be isolated. If you use subinterpreters instead, which is what I'm kind of building, I guess, here, they should be a lot lighter, and the memory usage for each worker should be significantly smaller. And then also, if there's a requirement to share data between the workers, which there will be, then that should be a lot quicker. Someone asked for the blog post. Hold on. Hey Alexis. Cool, that should be it. So yeah, when Python 3.13 comes out, which is next year, the stage I want to get to is that I can contribute a change, PR back to Hypercorn, that will basically have like a flag that you can run Hypercorn with subinterpreters instead of multiprocessing. Like that's my goal, because I think it will be quicker. I've not got to the point yet where I can benchmark it to see how much faster, but it should use less memory at least, which means you've got more memory to actually handle requests. And I think the throughput should be better, because you've got more system resources, and also the performance. So like the response time should be a lot quicker. It's also interesting to think about how that might be combined with the no-GIL work, because typically with Gunicorn you do multiple workers. Each worker runs on a CPU core, and then each worker has multiple threads, so each one has a thread pool. That's done because you've got some kind of concurrency. And I mean, if you imagine you're running a web server and you can only deal, I've got 4 cores on my machine. If I could only deal with 4 requests at a time on my machine, then my web server would be horrendously slow. Like all it takes is one person to make a request to like a slow part of the website that takes 10 seconds to respond, and then no one else can make a request to that web server at the same time. So like you do want concurrency, but the GIL's kind of been a bit of a bottleneck with the thread pools in the web workers. So I think that if you combine subinterpreters and no-GIL threads, then we're basically going to get this like super parallel web server. That's that's kind of the idea. So yeah, now that I run it with a debugger, what's this called, like a Heisenbug, it doesn't crash, which is typical. So like it's not going to run that assertion for me. Let's try it again. Come on, crash. So the issues so far that I found, so this is like a build of Alpha 1, 3.13 Alpha 1 with some like experimental flags on it. So like I'm not expecting this to be stable. Some of the issues that I found are related to the builds. So you see here in the name of the library, it says CPython 3.13 TD. So D means debug, because the interface for debug binaries is different to non-debug binaries. Darwin is the weird name of Mac OS, and T is the no-GIL flag. Like that's what the no-GIL flag will look like. So some of the issues I found last week. was, okay, there was that one, there was that one. Yeah, so this is one which I think is being patched. So the wheel package for Python. So this is how like alpha this stuff is. Like wheel wasn't working, which is kind of important. So you couldn't, like, if you downloaded a package, like you pip install a package, normally when you pip install packages, it goes to pypi.org. Let's pick a package name. Pydantic. That was one I was looking at. So there's been all this work done on Pydantic to write it in Rust, right? So if you're interested in that, Sam Colvin did a really interesting talk on it at PyCon US last year. He did a talk about rewriting Pydantic and Rust. It's really interesting. Now, you don't just download Rust source code and run it locally. Like, it needs to be compiled by the Rust compiler. And in PyPI, it will pick the compiled version of the Rust code depending on your platform. So that's why, well, there's two options, I guess. One is download the source code, which has the Rust code in it, and then it compiles the Rust locally. So if you've ever had an issue where you've installed a package like NumPy or something like that, and it sits there for like 5 minutes compiling stuff from source, and you're like, why the hell is it doing this? The answer is because pip couldn't figure out which one of these many wheels is the right one. And there's probably a good reason why, but there's like a special naming scheme in here. CP means CPython, 3.8 means 3.8, macOS means macOS. Many Linux is like a portable Linux build. So the Pydantic team have built pre-compiled basically like the Rust and the actual Python extension. They've pre-compiled it for you because they're nice, and they've uploaded versions for Python 3.7, 8, 9, 10, 11, and 12 for different platforms. So like ARM64 on Windows. Wow, they are really advanced. I don't see many people doing that. Muscle Linux, Many Linux. So they've got like all the flavors there, right? So, but I've requested, if I did a pip install, which I've already done, but if I pip install Pydantic core, like pip's going to look at that list and go, okay, well, I've got Python 3.13 with no-gil, which is like a special flag called T. It's not going to resolve to any of those. So it's going to download this source file and it's going to compile it from scratch. So that was one of the issues anyway I bumped into, was that wheel wasn't ready for that yet. That's still not fixed. They fixed the downstream issue, which was like the packaging needed the tag, but then wheel hasn't updated itself yet. Maybe next week it'll work. Other one I bumped into was that zone info doesn't work. And you can see this one if you run Django. So I tested Flask and Flask worked. I was really happy with that. I tested Fast API by installing an old version of Pydantic, because Fast API still worked with Pydantic 1. So I used that one instead. This worked, which I was impressed with. I mean, this is the simplest Fast API app I could think of. And I thought, okay, can I get Django working? Because that would be kind of cool. This is a single file Django script that someone sent called uDjango. This is kind of like a, yes, you can run Django in a single file. Now this one doesn't work, and the reason why is quite interesting. Okay, so Django fails to import. And the reason why, it says attribute error, module datetime has no attribute datetime C API, which is weird because datetime is a standard library module. And if I start Python and import datetime, that works. So that attribute does exist. So why is it crashing? The issue is, which is documented in this one, that it's not thread safe. Actually, it's not. I didn't think it was datetime specifically. It was like the zone info package, which uses something called a capsule, and was linked to another PR that somebody is already working on. So someone else is working on making datetime thread safe. So like that's kind of where I got to with Django. I think without datetime, Django is not really very useful because like it uses, I mean, actually no web app is probably going to be very useful without dates. But yeah, that was interesting. So I was like, right, Django doesn't work because no fault of its own. I mean, you can't, when you're in a subinterpreter, you can't import the zone info module, which it needs because it does like all this really cool time zone stuff. So yeah, that's why Django didn't work. And yeah, that's kind of where I got to, was that I can get Flask kind of running. I can get Fast API running with an old version. But I kind of found a few issues along the way. And I think once some of these are fixed, then I want to come back and test it again. But what it made me think though is it's always really interesting when you come across a bug. Well, when you get issues like the one I saw before. So, okay, this is one I was getting before. Like, this is a segmentation fault. And when you get an issue like that, you're like, okay, it's crashed. Why isn't there a test already in Python for that? And if you did add a test, what would it look like? Because, instead of just finding the bug and fixing the bug, you should always contribute a test along with it to make sure that it doesn't reintroduce itself in the future. Like, what's the regression test for that? And then why wasn't that picked up before? So with subinterpreters, what I was thinking about this week was okay, there's a test for subinterpreters. This is the test script, and it tests a bunch of things. So it tests like, can you raise exceptions in a subinterpreter? Can you print messages? Can you and this is where we did the shareable testing as well. So like, where is this further down? I think. Oh, can you start a thread inside a subinterpreter? Can you create dictionaries? All these kind of things. So what I was thinking about was, what are the odds of you can't really create a test to go and try and import every standard library module in a subinterpreter, because that would be a lot of test code. But CPython has like a big test suite already. And when you run like python.x in the build folder, so when you run Python, you can do -m test. And this is kind of like Python's, it kind of uses unit test, but it doesn't at the same time. It's got its own test suite, its own test library, its own test runner. It's like really bespoke kind of test environment. What I was wondering is, could I write basically write a test that runs. Could I write a test harness that runs the tests inside a subinterpreter? Because you'd get like you get a huge coverage of CPython by going and testing all the things that it's normally testing anyway, but running each of those tests in a subinterpreter. So that's just what I was thinking this morning was, is that possible? I might have a play with this after lunch and see if I can figure it out. But yeah, if anyone else has got any questions, otherwise we'll probably just wrap up because I'm running out of voice. Any other questions in the chat? All right. Yeah, if not, we'll wrap up. Yeah, thanks for coming and watching. But yeah, if you questions and stuff, just ping me on Mastodon or on Twitter, X, whatever it's called. And I'll see if I can answer. All right. Thanks, everyone. See ya.